Okay, so now we have to deal with beta 1 hat and beta 2 hat. I already know about the normality assumption of ui hat. I already know that ui hat follows normal distribution with mean 0 and variance sigma square. Now what do I have to do is mean 0. Now what I have to do is that I have to find out that beta 1 hat and beta 2 hat also follows normal distribution. So first of all, the rule says the following. If something, okay, what is the rule? The rule is if something is normally distributed, then anything that is a linear function of this must also be normally distributed. That is, supposingly I say that A is normally distributed and then I say that B is equal to 4A plus 7, then this B should also be normally distributed. This is the assumption, right? This is the rule. So now supposingly that I say A is normally distributed with mean 10 and variance say 4, and supposingly I say that B is equal to 4A plus 7, then I know that mean of B is equal to 4 mean of A plus mean of 7. So this becomes 4 into mean of A was 10 plus 7, this becomes 47. So the mean of B would be 47. Now let's come to the variance. So variance of B would be 4 square variance of A plus variance of 7. The variance of constant is 0. So this becomes 16 variance of A, and variance of A is 4. This becomes 16 into 4, which is 64. So I say that B is normally distributed with mean 47 and variance 64. And standard deviation of this would be under root of 64, which is 8. So I can also say that B is normally distributed with mean 47 and standard deviation of 8. So what I am basically telling is that if something is normally distributed and then I get another variable which is a linear function of that something, then this another variable also has to be normally distributed. So because B is a linear variable, linear function of ui hat, and ui hat is normally distributed, B has to be normally distributed. So what is the mean of beta 1 hat? It has to be beta 1, because I know that beta 1 is blue in nature, and I know what blue is that it has to be unbiased, and unbiased means that actually its expected value of the sample thing has to be equal to the population thing. Therefore E of beta 1 hat has to be equal to beta 1. Okay, now what is the variance? We have already done in chapter 3 the formula. The variance of this has to be summation xi square by n into deviated form summation xi square by sigma square. So this is the variance. So I say that okay, now beta 1 hat is also normally distributed with mean beta 1 and this as the variance, right? Why? Because beta 1 hat is linear function of ui hat. So similarly beta 2 hat is also normally distributed. So now I have proved that beta 1 hat and beta 2 hat are normally distributed. So now if beta 1 hat and beta 2 hat are normally distributed, they can actually be used, applied in the Z test. So what is the formula for Z? So Z is basically whatever your variable is minus its expected value upon the standard deviation of the variable. So I write this in form of beta 1 hat and I get this. So now what is the property of Z? Whenever I convert any variable in this form, so from beta 1 hat, if I convert beta 1 hat into this Z, where Z is beta 1 hat minus its expected value upon its standard deviation, the property of this Z is that this Z